Hi, hello, welcome back to our channel Chemistry with RK. Hope you're all doing well. So today's lecture we are going to discuss about the continuous discussion on our previous topic, that is preparation methods of alkanes. So in our today's lecture I'm going to discuss the next preparation method, which is one of the very important reactions in the preparation of alkanes. Anyway, this particular reaction is again going to appear in the coming few lectures also. So please, I request you to watch the video completely without skipping, and then please, I request you, if you are new to the channel, please do subscribe, and then don't forget to click on the bell icon to get the regular updates. I want all your support. I want you to like my video so that I can put more efforts to give you all sorts of information in a different way, in an innovative way. So without any delay, let us start our today's lecture on decarboxylation. But before that, please, I request you to be ready with your pen and paper so that you can dump all the information into your book, so that it will help you in the end of your preparation. So yes, the today's discussion is on decarboxylation reactions. So at the same time, parallelly, I am going to take few PYQs also, that is previous year questions, which are asked in JEE and then again in terms of NEET recent years, so that parallelly we can understand the concept as well as the problematic questions. Okay, yes, so let us see first of all, what do you mean by decarboxylation? So generally, decarboxylation is the removal of carbon dioxide from the molecules containing COOH groups. COOH groups generally contains in the carboxylic acids functional groups. When carboxylic acids react with sodium hydroxide, which is a base, then we are going to get this corresponding sodium salt of carboxylic acid. And now this sodium salt of carboxylic acid, upon reaction with soda lime mixture. So what do you mean by soda lime mixture? Soda lime mixture is nothing but 3:1 ratio of sodium hydroxide and calcium oxide, which is NaOH and CaO. So why do we need to particularly use 3:1 ratio of NaOH and CaO? Actually, the mixture of these two is called as soda lime mixture, which is generally used as a drying agent. So in order to make it to work as an effective drying agent, we need to take particularly 3:1 ratio of NaOH and CaO. So let's see, the decarboxylation is removal of CO2 from the molecules having COOH group, which is carboxylic acid. And then next, what exactly we are going to see in order to prepare alkanes by using this decarboxylation is, we are going to take sodium salt of carboxylic acid and we are going to heat this with soda lime mixture, which is 3:1 ratio of NaOH and CaO, gives an alkane containing one carbon less than the parent carboxylic acid we are taking. This is very important. So what does it mean actually? If we are taking the sodium salt of the corresponding carboxylic acid containing two carbons, then we are going to get an alkane with only one carbon. So where exactly the other carbon is going out? It is going out in the form of CO2. Yes, we know already. So that is what the decarboxylation mean. So one of the carbon in the parent sodium salt of carboxylic acid is being removed as a CO2, that is carbon dioxide. Always we need to understand one thing, that is, we are going to get an alkane with one carbon less than the normal parent carboxylic acid salt we are going to take. Hope you understood, right? Yes. So keeping that point in mind, if we take RCOONA, that is sodium salt of carboxylic acid. So firstly, I would like to tell you from where we are going to get this sodium salt of carboxylic acid. So you know very well that RCOOH, this is the carboxylic acid, and now when it reacts with NaOH, which is a base, so when acid reacts with a base, we are going to get its corresponding salt and water. So what exactly we are going to do is, hydrogen from acid and hydroxide from base, they are going to go out as water, anyway we know. And now the rest, here RCOONA, this is the corresponding sodium salt of carboxylic acid. So this is nothing but our salt. So once after we get this salt, we are going to react this with sodium hydroxide and CaO, which is nothing but the soda lime mixture. Yes, the soda lime mixture से react करने से what we are going to do is CO2 is going to go out as Na2CO3 and this hydrogen is going to combine with this R group, which is an alkyl group, to give us an alkane as the major product. Hope you understood. So let us take a simple R group, that is methyl alkyl group, in place of R, so that we are going to get CH3COO Na, which is nothing but sodium salt of ethanoic acid. So why we need to call it as sodium salt of ethanoic acid? Since this is the salt formed by taking ethanoic acid with a base, that is NaOH. So you know what I mean to say is, if we take in place of R, if we take CH3COOH and then reacting with the NaOH, which is going to give us that is CH3COONA, which is nothing but since this is ethanoic acid or acetic acid, we call it as acetic acid, and then we are reacting with the sodium hydroxide, which is going to give us sodium acetate, we call it as sodium acetate, or we can also call it as, since this is called as ethanoic acid, and this is called as sodium ethanoate. Yes, it is so simple to write down the names also, sodium ethanoate. And now, yes, since we are taking this sodium ethanoate, which is having 2 carbons here, but in the final alkane we are going to get 1 carbon less. So this CO2 is going to go out in the form of Na2CO3, giving us CH4 as the major product. So in our previous videos, we have concluded that Sabatier-Sunderens reaction, coal-base electrolysis, we can't prepare methane. By using this decarboxylation method, yes, we can 100% prepare methane, which is a unsymmetrical alkane or odd number of carbons containing alkane. So very important point. And then next, so in place of R, if we take C2H5, which is actually called as ethyl alkyl group, hence this particular sodium salt is going to be called as sodium propanoate. Since we have 3 carbons, sodium propanoate ko decarboxylation karne se ethane milega, because again I am repeating, one of the carbon will go out in the form of CO2. So only we will be getting the alkane with corresponding to the alkyl group here. Since we are taking C2H5, we will get C2H6 as the major product. So we can prepare ethane also. So next, this is benzoic acid. Benzoic acid, upon reacting with a base like NaOH, we are going to get sodium benzoate. Same thing we need to do. Since this is an acid and it is reacting with the base, you remove this hydrogen and then substitute Na. That is nothing but sodium salt of benzoic acid, or we can also call it as sodium benzoate. इस sodium benzoate को decarboxylation करने से ये पूरा ग्रुप को निकाल दो और उसके प्लेस में एक हाइड्रोजन लगाओ. Yes, we are going to get benzene. Yes, again this reaction we are going to get in the preparation of benzene. Hope you understood. Please you try to correlate the concept. इसमें हमको क्या मिला है? Benzene. So obviously this reaction again we are going to get in the preparation of benzene from sodium benzoate by decarboxylation. So next, similarly, let me take this particular acid is called as salicylic acid, having OH and then uska next position mein COOH. This is called as salicylic acid. And now salicylic acid, upon reacting with NaOH, like a simple strong base, that is, again we are going to remove water. We need to substitute the hydrogen of COOH with the sodium, which is going to be giving us sodium salicylate. So this is called as salicylic acid. This is salicylic acid, and this is the salt of the salicylic acid. We can call it as sodium salicylate. So sodium salicylate, or we can also call it as sodium salt of salicylic acid. Sodium salt of salicylic acid. Okay, and now this sodium salt of salicylic acid ko again we are trying to do decarboxylation. Yes, what we are going to get here? So you remove the COONA and then take just the hydrogen. So ऊपर जो OH group है वो undisturbed होगा, and then we are ultimately going to get phenol as the major product. Hope you understood? Right. So what we can understand is this reaction is again going to come in the second year phenol chapter as well. So please, this decarboxylation is very important in terms of organic chemistry. So this reaction is going to come repeatedly in the next coming lectures also. So please you try to understand that, and then yes, that is what I have given here. And then next, so in this compound you can see two COO-Na groups, that is dicarboxylic acid salts. And now this upon again decarboxylation, yes, we are going to remove both the COO-Na groups and then take just the hydrogens, which is going to give us pentane as the major product. Okay, let me give you some more examples. Like, you know, you have, suppose, let's say cyclopropane carboxylic acid salt, and then this upon decarboxylation. So this compound upon decarboxylation, yes, what is the product? You please ready with your answer. So this sodium salt of cyclopropane carboxylic acid gives us you know, just the cyclopropane. Yes, hope you understood well. Right. So just in place of this COO-Na, take hydrogen, that's it. Yeah, let me take some other example here. So if we take, you know, normal cyclobutane carboxylic acid salt, and then upon decarboxylation again we are going to get cyclobutane. So simply if we take sodium salt of benzoic acid, yes, sodium salt of benzoic acid, we have already seen this reaction, we are going to get benzene as the major product. So these are the few examples I have selected from past papers. So please, after watching this video, you please try to open any of the books, any of the, you know, materials you have with you to solve the questions related to this decarboxylation. So with this, I am going to end up my video, but before that I would like to request you to subscribe to my channel, and don't forget to click on the bell icon to get the regular updates so that you can enjoy watching our videos. Thank you so much. See you soon.